All right, so let's first of all go ahead and define what the angle is. So let's just draw the Earth here. Here's the equator at 0. Here is the North Pole at 90 degrees. Now, so the sun's over here. Sun. So the way these angles are measured is basically a panel sitting on the equator would be flat. It would be tangent to the Earth, and it would have 0 degrees. On the other hand, if you wanted to get maximum solar gain, you were sitting at the North Pole, and this would, I guess this would be on the solstice, when the sun is directly above the equator. The sun is just at the horizon at both the North and South Pole on the. I'm sorry, not the solstice. The equinox. On the 2 equinoxes, you've got the sun directly overhead, and the sun is right on the horizon at the North and South Pole. So your, let's just say it this way, what variable do they use for tilt angle? Is it theta, or do they use an actual symbol in the book? They use T for time. That's good. I usually just use theta. I might be another one. Let's see it. Anyway, let's just say theta. In this case, we're looking at the elevation equals the latitude. Right? So if you're at the equator, you want your angle, elevation angle on your panel to just equal whatever latitude where you are. And the same thing would be true here. Let's just say, so we're at, so here's 30, here's 60, we're here at 47. So if you had your, I'm just going to draw a few different extremes. So this would be 0, and obviously if the sun is coming in here, you're not getting your full effect. So this would be a 0-degree array. This would be 90. The sun's also coming in here, not getting your full effect. But if you instead tilted up at 47 degrees, so start at 0, tilt it up, and then right in between, here's basically 47. Now you're pointed right at the sun. So this is 90, this is 47, and you're going to get your optimum. And that's what the book says. So you're going to get as much as you can on both of the equinoxes. You're going to get shortchanged on both, well, you get shortchanged on both solstices. The question is, which way do you want to cheat the thing? So, and as it turns out, you actually want to cheat it a little bit more towards flat, because in the summer, that part of the Earth, the northern hemisphere, is going to be pointing closer, more towards the sun. So you're going to cheat it more towards what you'd have your panels look like at the equator. So the question is, so you start with 47, and then if we hop over to page 52, I'm just looking at this little map. Let's just look at the map on page 52. And so, yeah, and it's not, well, I think these are empirical lines. They're based on cloud cover, they're based on elevation, they're based on a lot of things, and so it's not a hard and fast dial in exactly, but it does look like to me that Missoula is right there on that boundary between 12 and 8, and if you sliced it up a little bit finer, I guess the question is the line the average? Is the line like 10 degrees? I'm thinking like the middle of that orange 8 is probably 8. The middle of that reddish 12 is 12. So the boundary between them is probably 10. So I guess what we're looking at is, in this case, 47 degrees minus, I'm just going to say page 52 data equals 47 degrees minus 10 degrees. And if we go back to the questions, equals.
So you just wanted us to use the 12?
Could be. Equals 37 degrees. And the answer was 35. Well, 35 is closer to 37 than anything else on there. So yeah, it could be just use the 12. And again, you know, these are engineering answers as well. It's never going to be exact. And when we dig into this a little deeper, I mean, we'll also see that 2 degrees. In fact, let's just do that really quick. If we go out into Microsoft Excel, and let's just look at the change in gain for a 2 degree difference. So here's 0, here's 1, here's 2, 10, 45. I'm just going to bang out a few of these guys. 88, 89, 90. I'll just put this in degrees, and I'll put it in radians. So this equals radians. So I'm going to convert degrees to radians because when Excel does trig, it wants to see the angles in radians. Now let's do cosine. We'll do sine. So equals cos. Equals sine. If I just drag these guys down. Okay. So what I'm showing here, and let's just put 2 significant digits on this, or actually let's put 3 significant digits on these. So really what you're dealing with in your solar is are these sine functions. So a sine at 90 degrees, that means the sunlight is perpendicular to the panel. You're getting all the sunlight, 100% efficiency. 2 degrees off, you're still at 99.9% efficiency. So that little 2 degree difference we just talked about, you're losing 1 out of 1,000 photons. So that's, yeah, okay. All right, so hopefully that clears those 2 problems up. Yeah, and I'm glad we went over them because, I mean, those really are pretty fundamentally important problems for this. Like, oh, how'd you pick your angle? Oh, yeah. Yeah. No, good. So I'm glad you asked those 2. Okay. What else on the test do we need to check out? So that was it. It's flubbed. Okay.
There's one question that asks you to refer to a graph that's supposed to be on the question, but the image is broken. Or at least it was for me.
Oh, really?
Yeah.
Let's take a look at that too. Sorry. And did you guys get to the topic 3 questions yet?
I haven't done the PV watch one, I did the first test.
Okay, yeah, take a look at that. I'll just leave it open. I just graded the first couple things first.
Play this weekend.
It's necessary.
Not me, I was just a big loser yesterday, sat around grading and doing taxes.
Fun.
We can do that. Do taxes.
Find one more W-2.
Somewhere in the world.
You said there was a screwed up figure for you there somewhere, Zach?
Yeah.
Which one was it?
It's one of the ones that was, I think it was like 3.
Okay.
And one was that same one we just went through.
Yeah.
Slow.
It's really slow over here.
But it's worked just fine on my computer.
This guy?
Let's see. No, not that. Yeah, that's one.
Oh. So there's a broken picture there, huh?
Yeah, and I wasn't sure if we were supposed to use the same sun test chart.
Oh,
for the
shoot.
questions.
Okay.
I mean, this one probably could figure it out without. it.
Yeah, bummer. Yeah, sorry about that. Referring to the sun path chart for 45 latitude, what's the lowest altitude of the sun? At the winter solstice.
This one that I think was probably in the book, and there's also.
Well, the image right there, you assume you had to use that one.
Yeah, yeah, it's like, oh, must be.
Well, I'm looking at the book, page 226, right? And that is the sun path chart. What is the lowest altitude of the sun between 10 a.m. and 2 p.m. on the winter solstice? So the winter solstice is the blue line.
What was that page again?
I'm looking on page, yeah, we're looking on page 48.
48.
Yeah, let's look on page 40. I think I can see that one now.
Yeah.
I'll just go ahead and redraw that thing.
It asks what's the lowest.
Yeah.
That would be both.
Well, here, yeah.
Two according to the chart.
Yeah, so here's the issue, and I'll see if I can do this thing justice. So here's the chart. There are 3 lines on there. There's a blue. There's a blue line like yay. That's the winter solstice. There's a green line like yay. Those are the equinoxes. I'll draw one more. Point red. And this is the summer solstice. So back to my black pen. The top of that curve is, well, it's halfway between 15 and 30. So I'm going to draw 15 right here. I'm going to draw 30 right about here. And so in each case, this is noon, 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 and these curves are symmetric. So 10 a.m. is about right here. And, you know, again, it's symmetric, so there's 2 p.m. So going back to the question, referring to the referring to the sun path chart for 45 degrees north latitude, which is what we just did. What's the lowest altitude of the sun between 10 and 2? Well, as it turns out, it's lowest, well, obviously it's highest at noon, and I'm going to call that, 22 degrees or so. But at 10 and 2, it's only at 16. So I think that's where that answer's coming from. Does that make sense?
Yeah.
Yeah. So the question is, in this area, what's the lowest? Well, it's right down there. So, okay. And that little figure, anyway, it's the same. So, okay. And I'm thinking these. I mean, these are probably going to be pretty typical questions for your NABCEP exam. These are things just you want to know and bang out pretty quick. So, all right. What else, guys? So hopefully we've done review here. Any other hang-ups moving through the course at all? I think I opened up week 4, so you can get in there. Oh, it looks like some people took the first exam, some took the second. I graded them both, and just, it's fine.
Are there going to be copies? Should we take like a certain one from now on? Or?
Oh, I think, let me see.
Yeah, looks good.
Yeah, I've been doing my best to delete the duplicates. Topic 4, yeah, I'll go ahead and open that up since it is week 4 now. All right, well, let's just do a little preview
At the
for
very beginning, the basics of electricity, there's 2 quizzes.
Yeah, that one. Yeah, it looks like people just took one or the other, and I'll be able to sort that out on the final grade, so don't stress about that.
So this PV Watts assignment,
Mm-hmm.
when I click on it, it just goes to a quiz. So it's not really an assignment, it's a quiz. Spread.
Take a look.
Anything for this PV Watts dot B.1.
Yes, so anything with a check that is, an assignment, an assessment, let's take a look at it here.
I looked at the calculator.
I was just looking, when I see assignment, I think,
Oh, preview quiz now.
Do this, do this.
Oh, right, yeah.
Or something.
I'll change that.
That's all.
Okay.
Curious.
Just poorly labeled. I'll take a quick look at it here. Have you looked at it already?
I have.
Okay, let's do a little preview.
I was just looking at your grading message.
Yeah. All right. So all this stuff is going to come out of that PV Watts calculator. And these aren't things you're going to do in your head. It's just going to be finding your way around the PV Watts calculator. The second part is sort of partial credit for doing it right. Do rate factor, show your results. Yeah. Yeah.
Is that online?
What's that?
The calculator, is that something we'll find online?
Yep.
Yeah. The
Yeah.
link to it's like right above the.
Yeah.
Okay, I've got mine.
The link's right next to the assignment. Tab.
Yeah, and the PV watts is more or less an industry standard, so dig into that. Yeah, this is about the slowest I've seen this web out here. Carlson's over there hogging all the bandwidth.
So you are changing that from a quiz to a assignment, so we can get into it one once, or is it going to stay quiz?
I don't mind. Here, let me just call it a quiz, because that's what it is. And I don't mind letting you have another shot at it. Is that what you're asking? Yeah, I can change those settings. Whew. Okay, come on, baby. Getting old here. QUIZ.
Start loading something, leave the computer alone for 8 hours, come back to it.
And again, like I said, I'm not going to be a stickler about due dates. This course has been developed by several individuals over the years, and really, for me, the important thing is that you get the material and that you nail the NABCEP exam. I'm not, and take as many shots at it as you want, get your grade. Take it again, improve your grade. I just want you to become, fast and proficient at these problems and understand them fundamentally. So if something goes wrong, you know where you made your mistake, and you're just guessing. I'll extend this out a little bit.
Right here.
Yeah, see, I clicked on that. And that's all that happens.
Oh, I thought the calculator's right there.
Really?
Yeah, the teacher goes. I thought the calculator was right above the assignment.
Maybe I can make it.
Those are little PDFs, that's it.
Yeah.
That was, maybe it's a broken link now.
Might be.
Let me take a look at it.
Yeah.
Okay, so I just extended the deadline on quiz 3, and I just gave you 3 attempts. Is that all you get to?
Yeah.
Just to, okay.
So it was the calculator at one point.
Yeah.
When did you see it?
Saturday.
Oh, really?
Yeah, I definitely checked it like a week ago.
But I mean, this is all you need right here is
Okay.
the NREL PV watts calculator. So, go. So there we are. So, here we can start putting in our parameters. Let's just do like a 2.5 kilowatt array, module type, standard sounds fine, array type, fixed. We can try a roof mount. System losses, snow. You can get into all this kind of stuff. Nameplate rating, age, et cetera, et cetera. Save. Tilt. 36 degrees. That's our best. Azimuth.
I think it's mostly relevant, you say in the northern hemisphere pointed south, so when you use it.
Yeah, it's 180. I mean, you don't want to cheat it east or west. I guess you could, but no reason to. So 180. Residential, fine, 9 cents. It's about right. Initial cost. This is pretty cool. Okay. Go to PV Watts results. .5 is what we put in. Fixed roof. Cost generated by the system. Find a local installer. Sweet. I want to see how much energy I get out, though. Where's that? Oh, there we go. Okay. So this is going to tell me, my best energy is coming out in July. 402 kilowatt hours. Yeah, 4.36. That's the number you usually use. I usually use about 4.4 hours for Missoula. 31.25 kilowatt hours. So you're making $291 worth of electricity in that year with that system. Pretty slick. Okay. It's noon. I think that's, anything else comes up, just email me over the course of the week, but I think we're making pretty good progress here. Hopefully we cleared up the couple questions on the exam. Because that's the kind of stuff, I would just, guys, I would just go back and practice that. Because what I don't want to have happen in, seriously, focus on the stuff that was not clear. Like in May, you don't want to be thinking, oh gosh, what was that problem I was thinking about in February? So go back into your and again, I can't make this point clearly enough because it happens all the time. It's like, oh, I hate online classes. Well, get out your pad, get out your pencil, do this, write stuff. Because once you've drawn it and you've seen it, and it's gone from the page to your hand, back to the page to your brain, it's easier. It'll come back to you quicker. Yeah. So have a notebook like that. That's what you're going to review right before you go into the NABCEP exam. All right, thanks, and I'll see you in a week. Yeah.